Hello, students!
Hello, visitors!
We've got a live audience today for our final video of the year. That's right, ladies and gentlemen. This is it. We are finishing up the year this year with our final topic on the solar system. And this video is about the two activities that you are going to be working on today. And I hope we're going to have some fun doing this. We're going to begin first with the blink comparator. What is that, you say? Well, if you were paying attention to yesterday's lesson, you know exactly what a blink comparator is and what it is used for. Well, today, in your books, on page 202, you're going to complete the classroom activity first. It shouldn't take all that long to complete, but you are going to be comparing the two images in your book and trying to determine if there is a new planet to discover. Yes, you may discover the brand new planet X. So use the information that we learned yesterday about the blink comparator to help you complete your classroom activity. But that brings us now to our lab activity. And during this lab activity, which will take the majority of our time together, you are going to attempt to create a scaled model of the solar system in the classroom. That's right. That's what I said. You're going to try to create a fully scaled model of the solar system in the lab. In fact, that is the problem stated in our book. It says, can a completely scaled model of the solar system be made in the classroom? So let me just take a quick moment to explain what exactly am I talking about when I say completely scaled model. You know about scales and models, but what's a completely scaled model? Well, here's the deal. As we've seen this week, the planets are of various sizes. We've got models of the planets of our solar system on display in the classroom, and you can see how much larger Jupiter is compared to Earth, and you can see the relative sizes of the planets. But what your objective today is to do is this. If you look at this page in your book on the observations section, you can see that there are different pieces of information, the diameter of the planets and the distance from the sun. And I'm giving you here the actual measurements of the diameter of the planets in kilometers, and I'm giving you the distance of the planets from the sun in millions of kilometers. And I've given you two scales at the top. A scale of the planets is 1 millimeter equals 1,000 kilometers. The scale of the planetary distances is 1 millimeter equals 1 million kilometers. What the question is really asking you is this. Can you create in the classroom a model of the solar system where the scale of the planet sizes and the scale of the planet distances is the same scale? Is it possible to achieve a completely scaled model of the solar system? To truly answer that question, we're going to complete the activity. And I have given you on the next page what looks like a cute frog face. It's not a cute frog face, however, ladies and gentlemen. All of those circles oriented in a way that looks like a cute frog face, these are the scaled sizes of the planets. I have already pre-measured them for you, and you're going to be using some scrap paper to trace the outlines of these planets and cut out the planets according to the scale in the book, which is, as I mentioned to you in the previous slide, the scale of the planets is 1 millimeter equals 1,000 kilometers. So you can measure these circles here and determine which circle represents which planet. I'll give you a hint. The largest circle represents the largest planet. And we all know what planet that is, right? Jupiter is correct. And the smallest circle is the smallest planet. And do we know what the smallest planet is, everyone? Mercury. Mercury, that's right. So as far as the planets in between, use the scaled measurements to help you out. Once you have your circles cut out, I'd like you to color them in and decorate them, make them look like the actual planets, because we're going to make our solar system look really cool in the lab. Again, use the scaled diameters here to measure the sizes of the planets according to the scale. And then what we're going to do is we'll have a long string in the classroom for a length of 5 meters. 5 meters will be long enough for us to place all of the planets in order from the sun to the farthest away. Then we're going to hold up our model and we're going to examine it and answer some questions. And the questions are on the bottom of the lab page. We'll answer those questions, discuss it, and see what you find out to be the answer to the actual question of the lab. Can we create a truly, completely scaled model of the solar system in the lab? Why or why not? So that's enough of me talking for now, because you want to get busy creating this solar system model. So until next time, I'm going to say...